Brine, a solution of common salt, sodium chloride, is the starting material for making three important chemicals by electrolysis. Sodium hydroxide is used for making soap, paper and synthetic fibres. Chlorine is used for plastics, water purification and insecticides. Hydrogen is used as a fuel and for making nylon and hydrogen peroxide. The principle of brine electrolysis is as follows. During electrolysis, hydrogen ions are discharged as hydrogen gas at the cathode. Chlorine ions are discharged as chlorine gas at the anode. Sodium ions and hydroxide ions stay behind as a solution of sodium hydroxide. The problem is to keep the chlorine gas and sodium hydroxide apart because they react together. Two types of electrolysis cell are used on this site: the flowing mercury cathode cell and the membrane cell. On this site, the brine is pumped from underground salt deposits and is treated here. Treated brine is carried to the mercury cells in this building. Membrane cell electrolysis takes place here. Chlorine is treated and stored here. Salt is obtained from underground deposits by solution mining. Salt deposits are some 300 metres deep. Water is pumped into the deposits and dissolves the solid salt. Air is pumped in and the saturated salt solution, brine, brought to the surface, where it's treated to remove calcium and magnesium compounds and carried by pipeline to the plant. Here it is acidified to help the production of chlorine in the electrolysis. This is one of the 106 cells in the flowing mercury cathode cell room. It produces 1/4 of a tonne of chlorine per hour and needs a current of 200,000 amps. The cell has a sloping base down which flows a stream of mercury. This is the cathode of the cell. 3 millimetres above the mercury are grids of titanium, the anodes. During electrolysis, chlorine is discharged at the anode. Sodium is discharged at the cathode and dissolves in the mercury, forming an alloy called an amalgam. When working, the mercury cathode cell is sealed. This cell is being cleaned, it's not working. This is the flowing mercury cathode that runs the length of the cell. Saturated brine is fed in at the high end of the cell. Sodium-mercury amalgam flows out at the bottom of the slope into a denuder, shown here with the top removed. The denuder is packed with balls of graphite which act as a catalyst. Sodium-mercury amalgam flows in at the top of the denuder. Mercury flows from the bottom and is pumped back to the electrolysis cell. The sodium reacts with water, forming sodium hydroxide. Hydrogen gas is released. The cell works most effectively when the distance between the titanium anodes and the mercury cathode is about 3 millimetres. The plant operator is adjusting the anodes. He can raise or lower the titanium plates. This is what is happening inside the flowing mercury cathode cell. Used brine is treated to remove traces of mercury and put into the river estuary. This room contains 53 membrane cells. Membrane cells are cheaper to install than mercury cells and easier to maintain. These particular membrane cells are electrolyzing potassium chloride. The electrolysis releases chlorine at the anode, hydrogen at the cathode, and produces a solution of potassium hydroxide. These cells use a current of around 80,000 amps, and these are the buzz bars carrying electricity to the cells. As with the mercury cells, chlorine is produced. Hydrogen is produced at the cathode. A membrane, hence the name membrane cell, keeps the chlorine and potassium hydroxide apart. Potassium chloride and dilute potassium hydroxide flow in opposite directions through the cell. Chlorine, hydrogen and more concentrated potassium hydroxide are produced. These are the layers of anodes and cathodes that are held close together to produce the cell. This is a polymer-based membrane that keeps the reactants apart. Concentrated potassium chloride enters the anode compartment where chloride ions are discharged as chlorine. This leaves less concentrated potassium chloride, which carries the chlorine out of the cell. Dilute potassium hydroxide enters the cathode compartment where water is decomposed into hydrogen gas and hydroxide ions. The membrane allows potassium ions to flow through from the anode compartment. These, along with the hydroxide ions, increase the concentration of the potassium hydroxide. The concentrated potassium hydroxide carries the hydrogen from the cell. In the electrolysis, potassium chloride becomes more dilute. Potassium hydroxide becomes concentrated. The potassium hydroxide, sometimes called caustic potash, is sampled to check its concentration. Chlorine can be tested by drawing off small quantities of the gas. The chlorine product is collected, treated and stored. It can be transported by road, rail and sea.